Okay, so now the double integral using polar coordinate system. So this one is in the Cartesian coordinate system, and now we want to solve the given double integral in Cartesian into using polar coordinate system, where the dA now is r d theta. Then how about the integration process? So exactly the same, which means that now you have to, now the r here will be part of the integrand. You have to consider this one as part of the integrand, and when you do integrate, if you put the r first, you have to integrate respect to r, and then after that respect to theta. So now we want to know how can we determine the limit in polar. Okay, so I will explain through the example. Okay, looking at example 1. We want to evaluate. So in this case, the information provided is in Cartesian coordinate, where we have okay. So now we look at the instruction here. You are given double integral. When you want to integrate, the integrand is x squared plus y squared plus 1 dA, where the region is a circle. Okay, so since it is a circle, so it is good if we can solve that, solve the double integral in polar, since it's more simpler. Okay, the way of integration, you will get a simpler step rather than if you proceed in Cartesian coordinate, where you need to apply the some substitution, where it is not a regular substitution, but you need to apply the trigonometric substitution. Okay, so now even though they don't ask you to convert or solve into polar, so meaning that if you want to proceed your integration in Cartesian, you still it is still possible. Okay, because there's no instruction that you have to solve this in polar. But let's say they mentioned that using polar coordinate system, evaluate the given integral and so on, then you have to. Okay, so let's say now because we want to learn how can we solve this in polar, so we convert into polar. Okay, so firstly what you have to do is the integrand itself. For the integrand, we have x squared plus y squared plus 1. So now we want to convert the function. Okay, let's say I'm using f, but it should be not, okay, cannot be the same, because your expression becomes, once you convert into polar, so your expression is different. So let's say I put g now in terms of r theta. So so you have to know the basic relationship between the polar and Cartesian. So the basic one is x is r cos theta, y is r sin theta. You have learned this before. Okay, and then we have the y over x is tangent theta, and also you have the x squared plus y squared is r squared. Okay, so now by using this relationship, so we know that this can be converted into r squared. So you have now g r theta is becomes r squared plus 1. So next we put into the now you got the new expression in terms of r and theta. So your x squared plus y squared plus 1 now becomes r squared plus 1. And we know that the dA in polar is r dr d theta. So just put r dr d theta. So as I mentioned from the previous video, the way you want to choose the order of integration for the direct, if you want to use the polar, so the common order of integration that we use is dr, and after that the theta. Okay, r dr d theta. Okay, so now we they are all in r and theta, normal x and y. So now it's time for us to determine the limit, because we as I mentioned before, the order of integration for the common one is r dr d theta. So now we want to look at the limit. So to get the limit, just like Cartesian, you have to sketch the graph. So as we know that the graph, the region lying on xy plane, it is a circle with radius 2, centered at the origin. So because of your limit belongs to theta and your limits belongs to r, normal x and y, then from the equation of x squared plus y squared equal to 4, you have to convert into polar equation. Okay, I'm sure that you still remember this. I don't remember which chapter that you were having this topic in Engineering Mat 1, but I'm sure that you have learned this before. So the region that we have is inside the circle. Okay, so now the way you want to determine the limit. Okay, let's say we're talking about the theta first, limit of theta, which is the outer integral. Okay, as we know that when you put the theta, when you put this in as outside integral, then your limit should be constant. Okay, so what is theta? Theta is angle. So now you have a complete circle. So your circle is when we say that it is a complete circle, so your theta should be start at theta equal to 0. So what is theta equal to 0? It is a line of the x-axis and start at x-axis positive. So this is x equal to theta equal to 0, and this theta equal to 90 degree, and this one theta equal to 180 degree, and this one theta equal to 270 degree. And then when you have this one, and you have a complete cycle, that is theta from 0 to, so 0 is a x-axis positive. You have a complete cycle, one cycle, so 0 to 2 pi or 360 degree. So remember, all the calculation you need to use in a radian. So don't use 360 degree. So use the 2 pi radian. Okay, because all the calculation is a number. Okay, so that is theta. Okay, how about if you have a semicircle? So let's say your region is semicircle, just half of the circle with radius 2. So how about the limit of theta? So this is what I explained. So 0 to pi. Okay, if you have the region is only lying on the first quadrant. So the first quadrant is located here, still part of the circle with radius 2. Why I explain. Then how about the limit of theta? 0 to pi over 2. So let's say your region. So your region is on the second quadrant, but also part of the circle with radius 2. On y-axis plane, should be on y-axis plane. So how about the limit of theta? So the limit of theta from 90, which is pi over 2, to pi. So as we know that for polar, they are very sensitive on the quadrant. Okay, even though you can see that, so this is the region. Even though you can see that the region of this and the region of this, they have the similar shape. Okay, but then they are located on the different quadrant. So this one, the first quadrant. So your limit should be 0 to pi over 2. And now look at the red region over here. The size of them are similar, right? But in terms of limit, you cannot put the same because, as I mentioned, for polar, they are very sensitive to the quadrant. Okay, the angle, where is the region lying on the y-axis plane. So in this case, it starts from the 90 degree or pi over 2 to 180 or 2 pi. Pi. And maybe you have you are given okay, let's say semicircle, but down there, third and fourth quadrant, also part of circle with radius 2 on y-axis plane. So this is your R. Then how about the limit of theta? So it is from pi to 2 pi. Okay, so hopefully you understand that. Okay, that is about the limit of theta. So now we obtain that for this case, the limit of theta is 0 to pi because we have a complete circle. So now we want to look at the limit of R. So limit of R means that R, what is R? R is the radius of circle. So you are very particular on the radius of the circle. Okay, now how can you read? How can you read the R? For theta, you read that from x-axis positive and anti-clockwise direction, right? But for R, how can you determine the lower bound and the upper bound? Okay, so the lower bound and the upper bound is based on the radius of circle. Okay, so let's say I give you R is from 1 to 2. So you know that your region is lying at the circle with radius 1 and the circle with radius 2. Okay. Okay, let's say I give you another example. This one is just about the region. Just I choose the random any random region. So you have 2R, this is 1, and you have another R, which is 2, okay, lying on y-axis plane. And then your region, your theta, okay, so now R is from 1 to 2, and then theta is from, let's say I want to have 0 to pi over 4. Okay, so now where is the R1, where is the R2? It is about circle. So you can see that, right? Just like a donut. You have just like a donut shape. So if you say that your region is lying between circle radius 1 and circle with radius 2, so this is supposed to be your region. If your theta is 0 to 2 pi, you have a complete circle. But now your angle is only between 0 and 45 degree. So for that case, so your theta, so where is theta 0? What is the line of theta equal to 0? Theta 0 is this line, right? That is theta equal to 0. And where is theta equal to 45 degree? So you have the line over here where the size of the angle, this is pi over 4. So now again, we repeat that our region is bounded by the circle with radius 1, circle with radius 2, and angle 0 and the angle 45 degree. So please shade where is the region should be. So as we can see that the region should be bounded by that 4 equations. So the possible region is lying inside here. Is that correct? Yes. Okay, so that is your R. Okay, now we go back with this example. So we have a complete circle. So just now theta 0 to 2 pi. How about the R? So the R here, what is the highest circle that we can see? 2, right? Isn't it? R is radius. So the radius of the circle is 2. So here you have the 2. How about what is this the smallest circle that you can see? So since you can't see any smaller circle, meaning that the smallest R is at the origin. So what is the equation that telling you have a circle with no radius, which is at the origin? So R equal to 0. So we know that when R equal to 0, imagine you have a circle centered at the origin with no radius. So it is actually just a dot. Right? So that's why we put the limit of R is from 0, which is lying inside here, 0 to 2. Okay? So that is the limit of this example where theta just now 0 to 2 pi and R 0 to 2. Okay, now you can see that all the limits for R and all the limits for theta, they are all constant. So what can you say about the region for polar where all the limits are constant? If we have a rectangular region, so when what is the shape of region when you can have all the limits are constant? When we have a rectangle, right? Okay, but in polar, you can see all constant when your region is a circle centered at the origin. So you have to remember that. For Cartesian, when your region is rectangle, so the x and the y, they are all constant. The limit of x and limit of y, they are all constant. But in polar, if you can see the circle centered at the origin with some value of the radius, so all the limit of R and the limit of theta, they are all constant. So please bear in mind. Okay, but if let's say I give you a polar equation, okay, for example, I give you a polar equation. Let's say your R, you are given a function in polar sine theta or 2 sine theta. R equal to 2 sine theta. It is also polar equation, but because they are in terms of theta. But this is not circle. If you remember the graph of this particular equation, and this is not circle centered at the origin. So when you draw okay, what I want to explain to you is what is the difference of R2 and 2 sine theta. So you can see that this one are constant, right? And this one is a function. And what is R equal to 2? You have a circle. You have a circle centered at the origin. And 2 sine theta, you have also a circle, but the center is not at the origin. So again, bear in mind. Okay. If I give you a quick question in quiz is, for example, I give you a circle centered at the origin. So you know that your R should be constant. Okay, but I give you another polar equation where the graph of that particular equation is not a circle centered at the origin. So so you know that part of the limit of the R, or of course R is a function. Okay. Okay, now back to the question here. We want to solve this. So now we don't forget the r single r here will be part of the integrand. So your expression now becomes okay, you have two options here, whether you can apply the substitution where you let u equal to r squared plus 1, and the r outside here can be cancelled out, and then you can just directly integrate, or you can expand. So it is up to you. You want to use substitution or you want to just expand first. So let's say I want to expand. So I have r cubed plus r dr d theta. So integrate with respect to r first. 1 over 4 r4 plus r squared over 2. And then I replace the limit r from 0 to 2. So 1 over 4, 2 to the power of 4 plus 4 over 2 minus 0 d theta, and you will get a constant. So 16 over 4, so you have 4 plus 2 4 will give you 16. 16 divided by 4, we got 4, so 4 plus 2. This is constant, and you have d theta. So 6 theta 0 to pi, and this will give you 6 to pi minus 0. So you got 12 pi. Okay, so now after you convert into polar, now look at here. This is Cartesian. Now you convert them everything in terms of r and theta. So why you need that? Because your region is a circle. So now after that, you just integrate directly because it's just a polynomial. Then you will get the answer. But if you proceed to solve this using Cartesian, because of your equation of your region is x squared plus, this one. The equation of your region, there is in the square root plus minus. So then your calculation will be more complicated, but still possible to be done, but more complicated than this one. So this one is just a direct integration. Okay, now look at the example 2 for the polar polar Cartesian. Sorry, polar coordinate system. You are given, so this one is a test in 2009, 2010. You are given an expression, and they mention that use polar, so you have to use a polar. Where your R is a region, where that region is bounded by the circles of R equal to 1 and R equal to 2. Okay, so in this case, it is okay for you to not sketch the region because you can imagine easily. Okay, because some question there is no mark for the sketching, but it is good for you to just provide the sketching just in case it will help you to get marks. Okay, even though the mark for the sketching is not provided. Okay, but let's say your sketching is correct, but then there is something careless mistake when you answering, when you determine the limit. So at least lecturer can refer to your sketching that he or she know that you were thinking something correctly, but just you did something careless mistake on the paper. Okay, so we have two circles, 1 and radius 2, 1, 2. So you have a donut shape, so your region is lying inside there. So that is your region. Okay, so now you can immediately determine the limit of theta, because you can see that your region is a part of circle centered at the origin, so meaning that all your limit must be constant. So now you can determine the limit of theta. You have a complete circle So 0 to 2 pi. Then your R. Okay, so from the previous example, I've forgotten to provide the line. Just like the Cartesian, if x constant, you have to provide the vertical line. For y constant, you have the horizontal line, right? Remember that? But for polar, you also have to provide a line, but the line is not just a vertical or horizontal. But in polar, the line is a line which is starting at the origin, and you can go that way, you can go this way, you can go many ways. You can provide many lines where that lines is starting at the origin. Okay, so now you can see that your region is between the 1 and 2, right? So meaning that in this area, there is no shaded region. The shaded one is between 1 and 2. So what you can see that just like you have the x constant, y constant, I always say that you are walking slowly upward or to the right, isn't it? But now for polar, imagine you are standing, sorry, it's too large. You are starting from the origin, that is your starting point, and then you keep moving slowly. It's nothing, so no region. But the first point that you can see on the region is this one, this point. And then the terminal point that you can see is that point. So now R. So the first point that you can see, it is the lower bound, and the highest point that you can see, that is the upper bound. So the lower bound here is belongs to R equal to 1, and then you keep moving this way, and the highest point, I mean the maximum point or the terminal point, is belongs to R equal to 2. Okay, so actually same as from the previous example, you draw a line starting at the origin. You draw a line, or you can have this line and that line. You can provide many lines, and then you are starting over here, and you can see that region on that point. So now you can see that R is 0, and then you keep moving, and then this is the terminal point, and that terminal point is belongs to 2. Okay, and similarly for this line, you will also have the similar limit. This is R0 to R2. This one R0 to R2. Okay, so you can see that for every angle, every quadrant, the lower and the upper bound, they are all the same. Just like this one. Okay, so now we can solve them, this integral in polar. So we know that 1 over 1 is fixed number, 1 plus, and we know that x squared plus y squared is r squared, and then what is dA in polar? R dr d theta. So the limit of theta is 0 to 2 pi, and the limit of r 1 to 2. And you can see they are all constant because you have your region is part of the circle centered at the origin. Okay, so now it's time for us to solve. Okay, to solve the integration. So what is the technique of integration? The most suitable one here. So you can see here you have, okay, I just settle down this outside first. So you have the, okay, let me change the color. So you have the r over 1 plus r squared dr. So of course you cannot use the partial fraction. Okay, it doesn't work, I think. And also by part. So but then the first that we can try is substitution. Okay, how can you know that substitution works? So normally what the thing that you should know about the substitution, if you can see that the when you differentiate, so we don't choose u equal to r, because the idea is, okay, what is actually you are doing when you do the substitution? You want to simplify the form, right? So now we expect that when you assume that u equal to 1 plus r squared, and you will differentiate, right? You will got to r, to r, and so on. So the r there will be will make sure that the r over here cancel out. But we hope so. Okay, we should try then. So now we let u equal to 1 plus r squared. Then you need to replace the dr there. So you have to differentiate du over du dr is equal to 2r. So now your dr is du over 2r. Okay, now we substitute back. So r over u. Okay, and then your dr is du over 2r. So then the r here, the single r here can be cancelled out, because of you assume that u is 1 plus r squared, and then you want to replace the dr here, so you need to differentiate. So that's why the substitution works here, because you want to simplify the form. So the answer, it just become 1 over, it's not the answer yet, but you manage to simplify the original form here into 1 over u du, in terms of u, when you will get a simpler form, but in terms of u. So now we integrate 1 over u. What is the answer? Ln u, right? Ln u. Okay, so ln u, or in terms of r, so ln of 1 plus r squared. Okay, so what is the limit? The limit of r is 1 to 2. Okay, so 1 to 2, 1 to 2, r equal to 1, r equal to 2. So I can put the half outside. So now I'll solve for the ln of 1 plus 4 minus ln of 2. Okay, and then I will get ln 5 minus ln 2. So you need to use a calculator to find the value. So when you use a calculator, so always leave your answer in 4 decimal places. Okay, if they put a specific decimal places, then you have to follow. Otherwise, you just give 4 decimal places. So that is the answer for the inner integral. So now your answer becomes 0 point. So just now you have a 0 point. What is that? I don't remember. 4582. 4582 d theta. 0 to 2 pi. So now you have 0 to 4582 is a constant, d theta. Then 0 4 582 theta, 0 to 2 pi. So 0 4 582 2 pi. And multiply by 2. So 0.9163 pi. You can leave your answer in terms of pi, or you can just multiply. Okay, so when you evaluate, so you will get this in 4 decimal places. But the given answer here, they don't evaluate. But please always compute. Okay, but we do not know what is the final answer in the answer scheme. So always try to evaluate. Okay. Okay, if you look at the slide here, before the example 1. So there are, just like Cartesian, there are 2 types of region. For the Cartesian, we have a rectangle and non-rectangle, right? But for polar, we also have a rectangle. Polar rectangle means you have your region is part of the circle centered at the origin and bounded by the theta equal to constant. So you have this particular shape. Okay, So the way you can determine the limit is just like what we have done for these two example 1 and example 2. But let's say for the next case that we want to look is a polar non-rectangle region. Okay, polar non-rectangular region, where instead of we have the region is bounded by the circle center at the origin and bounded by the two lines for specific theta. So your r is a function, it's not a constant. Okay, so that's why you can any shape, but the shape is not like this. Okay, so that is called polar non-rectangular region. So what the thing that I want to stress out here is your limit of the r is no longer a constant but a function. Okay, so look at the example here.